Hello everyone. Previously we had discussed on the cadence algorithm, right? So we are going with the array based algorithms, right? So first we had discussed on the cadence algorithm. So today we'll be discussing on the prefix sum or the difference array, right? So prefix sum or the difference array, right? So prefix sum usually we have made use of the prefix sum along with the segment tree and the Fenwick tree, right? So for the this one, cumulative sum or the prefix sum, we have made use of it. Usually, we make use of it for the segment tree, Fenwick tree, as well as the this one, sparse table, basically, right? So now let's see. Let's come to the definition part. I'll just come to the definition part here. What it says, let's see first. So here, prefix sum, also known as cumulative sum, is an array where each element at index I, where each element at the particular index or the index I stores the sum of all the elements from the original array up to I, right? So simple again. So prefix sum, also known as cumulative sum, is an array where each element at index I, what it does, it stores the sum of all the elements from the original array up to I, right? So it allows answering the range sum queries, nothing but the sum of array of left to right, right? So left to right, right? And big O of 1 after an big O of n pre-processing, right? So this is very important. It allows answering range sum queries, nothing but sum of array of L to R, nothing but left to right, and big O of 1 after and big O of n pre-processing. Simple. Now, let's discuss some. We are done with the definition part. Let's discuss some important points here. So, to compute an prefix array, to compute the prefix array, sorry, where prefix of I equals, so we'll be going with the prefix of I equals array of 0, first element at the 0th index, array of 1 up to array of I. So, this is the formula basically, right? So, to compute the prefix array, so we'll be going with the prefix of I or iterated value of the prefix equals array of 0 plus array of 1 up to array of I. This is fine. Then the sum of any subarray, nothing but the array of L to R, nothing but from left to right. So inclusive is this one, prefix of R or the right if L equals 0. If left is 0, then prefix of R, right? So otherwise, prefix of R minus prefix of L minus 1, right? Sum of any subarray array of L to R, nothing but inclusive here. This is, so basically when L equals 0 or if L equals 0, prefix of R will be going with the prefix of R. Else if L is not equal to 0, then we'll be going with the prefix of R minus prefix of L minus 1. Simple, left minus 1, right? So these are some of the use cases, man, I found. So this one I wanted to explain. These are some of the use cases where we make use of the prefix sum, basically fast train sum queries, right? So we'll be going with a so we'll be making use of this one, prefix sum or the difference array within the fast range sum queries. And also this one, converting repeated range sum range queries from big O of length to big O of 1. So here I explained, I think, right? So in big O of 1 after big O of n pre-processing, it allows answering range sum queries, sum of this one array of L to R in big O of 1, right? After big O of n pre-processing. Sorry. Here we are going with the fast range sum queries. So the use cases, we can go with the fast range sum queries, converting repeated range queries from big O of length to this one, big of 1, 1D and 2D cumulative sums, and also difference array tricks for fast range queries. These three, right? Basically fast range sum queries, 1D and 2D cumulative sum or the prefix sum, and difference array tricks for fast range updates as well, right? So these are some of the use cases. I found these three very important, so I just wanted to convey the same, basically. Right, so this is fine. Now let's try to understand the same thing with a very simple example, man. Right? So let's go with a very simple example. So I'll just go with def here. Let me go with a function name, build prefix. So this is fine. Let me pass the parameter array here. So now first what we need to do, we have to create a list of zeros of same length as array just to hold the prefix sums, right? So here I'll just go with a prefix. I'll just go with prep. This one we have to hold the 0 as I've said, right? So this one will be 0 into length of array. So let me pass array here. This is fine. Now let's iterate through array with index and the value, right? So I'll just go with I comma val and enumerate. So this one of array. This is fine, man. So here within the for loop, so if I equals 0, meaning, so when I is 0, the first prefix is just the first element. We know this one, right? Accordingly with the definition, the first prefix is just the first element. Means I can just write it in this way. Sorry, I'll just miss the column, I think, column, I think, right? So this one will be prefix of I. Uh, this I have to assign this one to the value. This is fine. Now, let me go with else here. Else when I is not equal to 0 or when I is greater than 1. So now I is greater than 0. So then we have to go with a cumulative sum, right? So nothing but previous prefix plus current value. Simple. So I'll just go with prefix of I. This one will be uh, prefix of previous one, right? So this one will be I minus 1 plus value. Simple. Right, so finally what we need to do, we need to return the computed prefix array, right? So what we need to do, we need to return the computed prefix array. So I'll just go with return pref is the keyword I have used, right? So this is fine. Now let's go with a range sum, right? So we have built the prefix array. Now we have to go with the range sum, quite obviously. So I'll just go with a one more function here, range sum. So this is fine. Let me pass pref here l comma r. So this is fine. Within the range sum function, so we have to return the sum of array of left to right, that is inclusive, using the prefix array. We know this one. Nothing but in simple terms, when l is equivalent to the value 0, right? So I can just write it on this way. If l equals 0, then what we'll be doing, we have to go with the sum from 0 to right. Nothing but 0 to r is just the prefix r, right? So in simple terms, when I say we have to go with the sum from 0 to r, is nothing but we have to return prefix of r, nothing but prefix of right. So I'll just go with return prefix of r. So this is fine again. So now let me do one thing. Otherwise we have to subtract the prefix up to l minus 1, right? So I'll just go with here, let me go with return. This is fine. Prefix of r, this is also fine, minus prefix of l minus 1. So this is also fine, right? So we are done with the coding part, right? So let's test the code, or let's go with a sample usage, right? So I'll just go with let me go with array of some elements here. Let me go with random elements 3 1 4 1. I'll just go with some other numbers 5 9. So this is enough, I believe, right? So this is just the sample array, man, right? So let's go with the print. Let's print something just for the interactive purpose, right? So I'll just go with let's show the input array. So I'll just go with original array here. This is fine. Now let me pass the array here. So why this is not showing? Oh, this one I have considered like this. I have to assign this one to the values, right? So this is fine. Now this has to show actually. Yeah, this is fine. Now we have built the prefix sum already, right? So let's do one thing. Let's build the prefix sums for the array, the example array that we considered. So I'll just go with prefix here. This one, let me assign this one to build prefix of the parameter array. So this is fine. Now let's print something for the interactive purpose. So this one will be prefix sums. So this is fine. Now let me pass pref or the prefix. So this is fine. We are just showing the prefix array, man. So let's go with the queries as L comma R, nothing but the left comma right pairs, that is inclusive indices. So I'll just go with queries here. So this one will be 0 comma 2, this one 2 comma 4, so this is fine. 1 comma 5. So let's go with the for loop here. So this one will be L comma R and queries, this is fine. So within the for loop I'll just go with s equals, so this one will be range sum. Let me pass prefix this one prep, so L as well as R, this is fine. So we're just computing the range sum and big of 1 here, right? So this is fine. Let's print something for the interactive purpose. I'll just go with print. So this one will be f sum array. So I'll just go with, let's do one thing. We're just going with the string interpolation here, right? So this will be fine. L2, basically let me pass R as well. Yeah, this is fine. So let me do one thing. So let me pass S here. This is fine. Yep. Now we are done with the coding part. So we are just printing the result with inclusive indices right here. So the line number 37, what we are doing, we are just computing the range sum and big of 1 as per the definition. And finally, in the line number 38, we are just printing the result with the inclusive indices, right? So if I try to run the code, so all the output that I need to get here is original array 314159, the same one, right? So 314159, we are just printing the original array here. So then prefix sum we have to get here as 3 4 8 9 14 and 23, right? So 3 4 8 9 14 and 23. This one we are just printing from 0 to 2, this one 2 to 4 as well as 1 to 5, right? So here in this case print this one whatever I have given here. This one basically we are printing from 0 to 2, 2 to 4 and 1 to 5. So we need to get the output 8 10 and 20, right? So let's see the same whether we get the desired output or not. So I'll just go with the Python. So let me copy this one here. I paste it over here .py, file name .py. So see here, original output, original array, we are getting 314159, right? Prefix sum, so we are getting, we have calculated the prefix sum from this one, this original array. So we are getting the correct output 3 4 8 9 14 as well as the 23. Nothing but here first we will be considering 3 itself for the prefix sum. Next we'll be going with 3 plus 1, nothing but 4, so we have displayed that one. Next we'll be going with first 3 elements, nothing but 3 plus 1 plus 4, nothing but 4 plus 4, this will be 8 itself. Next we'll be going with a 4 this one elements, this one will be 8, basically 8 plus 1, this will be 9. So next we'll be considering 5 elements, so this one will be 9 plus 5 14. Finally we'll be considering all the 6 elements, right? So this will be 14 plus 9, nothing but 23. We are getting the correct output, right? So prefix sum 3 4 8 9 14 23, absolutely correct. Next we are just printing sum of the array from the indices 0 to 2, 0 to 2 nothing but from 0 to 2, this one, right? So this one has to be sorry, this one original array 0 to 2, 0 we have at the 0 and 0th index we have 3, 0 to 2 means from 3 1 4, means 3 plus 1 plus 4, we have to get the output 8. Same goes with 2 to 4, we have to get the output 10 and 20, similar way, right? So we are getting the absolute correct output. 2 to 4 means here in this case, this one is 2, 2 to 4 we have to consider 2 3 4, right? So this will be 4 plus 1 plus 5, nothing but 5 plus 5, we are getting the output 10. So next we are going from 1 to 5, right? So this one is 1, this one 2 3 4 5, right? From this one to this one we have to go with 1 plus 4, nothing but 5, 5 plus 1 6, 6 plus 5 11, 11 plus 9 20, we are getting the correct output, right? So this is it basically for the prefix sum, right? So this is it for the prefix sum, we are getting the absolute correct output, right? So let's quickly go with the complexities as well as the notes part. So here, what will be the complexity here? Basically, we are going with the pre-processing, right? So nothing but the build part I'm speaking of, right? So pre-processing here, I'll just go with pre-processing, this one, right? So pre-processing, it takes pico of n. Pre-processing takes pico of n time to build the prefix array, and so it takes this one big of n extra space as well, right? So this will be extra space will be pico of n, right? So this is fine. Next, query time is this one accordingly with the definition. Query time is big of 1 per range sum query, right? So query time, so I'll just give here pico of 1 per this one range sum query, right? So this is fine. This basically works with the negative numbers as well, right? So this not only works with the positive numbers, this one works with the negative numbers as well, right? So, and it works with the Python's big integer as well, big integers as well, right? So no extra work is needed for the overflow here in this case, right? So this works with negative numbers as well as Python's big integers. Just keep this in mind. And one more thing, when I speak of the variants, so when I say variants, so 2D prefix sums will be making use of 2D prefix sums for the matrices and difference arrays, just to handle the this one many range updates efficiently, right? Just keep this in mind. So this is fine. Let me or comment this one, right? So this is fine. So we are done with the prefix sum or the difference array part, right? So let me quickly summarize whatever we have learned so far. I hope the this one, what do we call, prefix sum algorithm, is completely clear, man, right? I hope. Now let's do one thing. Yeah, let me summarize whatever we have learned so far. So prefix sum, what it does, it lets us pre-process an array into cumulative sums or the prefix sums. So inclusive range sum array from L to R can be answered instantly with the prefix of R minus prefix of L minus 1, right? So it's very simple, fast for repeated queries, and foundational for many problems. When I say foundational for many problems, it may be range queries, offline algorithms, 2D sums, and difference array updates, right? So just keep these things in the mind. So we are done with the prefix sum topic. So we are done with the prefix sum algorithm. Next, we'll be discussing on the this one. What do we call sliding window algorithm, right? So for now, this is it. Thanks for watching, guys.